Hey robot fans, welcome back to my chopper build. When we left off last time, we had some functional dome rotation and even got Chopper's nod functionality working. In this video, we're going to try to tackle what is arguably Chopper's coolest feature, the head arms. So let's get started by reviewing that. Okay, so if we go back to the file I used in part 1, we can review the functionality of the head arms. We want the arms to come out of the head, obviously. From there, they can rotate from the shoulder along the z-axis, rotate from the elbow along the z-axis, rotate from the shoulder again, but this time along the x-axis, which would rotate the entire arm. And on top of all that, we want to get the pincers at the top to open and close. The next step is going to be building the models for all the parts of the arm while keeping this functionality in mind. Here you can see I've masked everything out for the arm according to some pictures I found online. My plan is to attack this in stages where I'll refine the parts both aesthetically and functionally as I go. Stage 1 will be the pincers. I think in my head at least this one is the most straightforward for how it's going to work. I'll have to modify the size of the forearm to fit the servo, so that will affect everything else down the line, so I want to get this one out of the way. Stage 2 will be the elbow. Again, this one is pretty straightforward, so getting these first two easier stages functional before I tackle the rest is probably a good idea. Stage 3 will arguably be the trickiest. It's the shoulder mechanism that will control the movement along both of the axes. And right behind that on the tricky scale will be getting everything to move in and out of the head. This is the only stage where I don't really have a good solid plan of attack yet, but hopefully by the time I get there I'll have thought of something. But for now, let's get moving on stage 1 with the pincers. Okay, here's what I came up with for the main part of stage 1. Here's my pincer piece. If we move it off, you can see it has a recess for the hub here and a recess for the axle. So if we move it back, an axle will thread through there. Chopper has a couple little end caps on the sides of his axle. The rotation from there will go from here to here. And I have an end stop set up right here on the hub. And then there's a natural end stop at the bottom from where the pincer hits the hub. So the rotation is constrained a little bit by its own end stops, which is perfect because I did some testing without those end stops and they were super floppy and went all over the place. So from here, I have a hole in the back of the pincer. If we go into X-ray view, you can see that that hole starts off pretty big, moves down to practically nothing, and then reopens up here. What I'm going to do is thread a piece of wire through there, tie it off inside the big recess. It'll travel through that little hole, through the hole in the end stop, and then down into this hole here, which will put it, which will put it into the arm. And then from there, it'll travel down the arm, and there'll be a servo right here, which will pull the whole thing. And when the servo pulls, it'll come to here. When it releases, it'll go there. So pull, release, and that'll give us our pincer closing and opening. Obviously, this will happen on both sides, not just on the right side here. So let's get those printed out and see what that looks like. Okay, this is what that looks like all assembled. After I printed out the parts, I added in a temporary 3mm brass axle to each of the pincers. Then instead of tying off the wire, I thought it'd be a good idea to solder the end of it with just a little bulb of solder. This will catch onto that recess in the back of the pincer. After that, I threaded the wire through all the holes on both sides, and we end up with this. You can see we could pull it closed and open, just like the servo is going to do on the inside. So the next step is going to be printing out a little test arm, which we can insert the servo and write up some code to see if we can get the servo to do the open and close action. Okay, I printed out a little test arm here with a cutout, and I mounted a nano servo to the bottom. I then attached the wire to the arms of the servo horn. I just used the Arduino servo example sketch and made a simple. So all the code is doing is telling the servo to write to 180 degrees and then wait a second, write to 90 degrees, wait a second, 180, 90, so on and so on. Here's that a little bit faster. I think this is working pretty well. The only problem I'm running into right now is that when gravity's not on your side, the claw doesn't open quite as much. So basically this light gauge wire isn't actually pushing the claw open, it's just creating slack, and then gravity's pulling the claw down. So I'm going to experiment with some heavier gauge wire to see what that does. Even if it does nothing and it stays like this, I would be totally happy. It's just a little bit of a less opening when it's not upright. So I'm going to move on to the elbow for now and see if we can get that working. Okay, so phase 2 in this elbow. You can see it here if we remove this lower arm for the time being. You can see it's just a cap that attaches to the bottom of the forearm. And it's going to operate in the same way as the pincers do, where it's just being pulled into place. Only I don't think we're going to be able to get away with those loose wires that don't defy gravity. So we're going to use a 2mm rod to push and pull this one. So the way that that's attached, if we put this elbow joint into X-ray mode, you can see I have a little axle that threads through just above the center. There'll also be an axle in the center, but this one's just above. And then there's this little coupler here. This will be 3D printed. It accepts the axle for this and also has an opening for the 2mm rod that'll come out. And when that's being pulled, the whole elbow gets pulled up 90 degrees. So what's pulling that elbow is if we just unhide that arm again. And we unhide the servo here. We can see I have a servo that's going to attach to the back of the arm, and then that is going to pull that rod from here and just give us that little bit of movement that we need to pull the elbow upright 90 degrees. Okay, so I glued the elbow onto the back of the upper arm, and I glued the servo onto the back of the lower arm. I threaded that axle through that hole to attach to the coupling, which will pull the rod. Then I slipped that rod through the lower arm. I added in the main axle, which everything will pivot around, and then I attached the servo using a couple of screws, and finally attached the servo horn, which brings us to here. If I move this manually, you can see that the servo is moving. This whole piece is needs to be refined a little bit. I had to cut out some parts here and back over here. I had to cut out a little bit just to make all these rods fit and everything. I'm going to have to move this servo a little bit back, but for now this is great for the test. I've wired it into the Arduino, and I have the Arduino running the example sweep sketch. I just changed the values of the sweep from 180 to 90 just to give it a little less movement. So if we turn this on, we can see that it moves, but the problem is that it moves past its endpoints. If I can guide it so that it doesn't go past its endpoints, the servo is fine. But once it goes past those endpoints, then the servo doesn't have enough torque to hold it. So basically the servo doesn't have enough torque to hold it at its soft endpoints. So I'm going to have to install some hard endpoints on the model here just to get it to stop where it needs to stop. So I want it to stop here, and I want it to stop here. You see, it's just very happy to go past those two endpoints. Okay, I've added in a hard end stop here at the bottom and here at the top. That'll constrain the rotation from 90 degrees down to flat. So if we power this back on, see that you get the motion. It's pretty good. It's hitting those end stops pretty hard, so I probably have to change the values of the rotation a little bit. But for the most part, it's working. There's definitely enough torque in the servo to at least pull it, and this is only running at 5 volts. The servo is actually rated to run 6 volts, which is what it will run in the final version. So I can see the servo wire here is getting stuck, so that's got to be routed a little bit better. But I think that works for the most part. So let's move on to the shoulder joint, which will definitely be the hardest part of this mechanism. Okay, so here's the arm in the current state. I have those end stops that I printed out in the digital file here. When I go through and do the final refinements for the final arm, I'm going to integrate these into the lower arm here. It'll make it look a little bit more finished and a little bit more buttoned up, but for now they're fine for these tests. So moving on to the shoulder, we have the elbow rotating like this, and we need the shoulder to rotate along the same axis. To do that, we're going to use the HS805BB Plus servo, the same one that we used for the nod function. And that's going to rotate the whole arm like this. But in addition to that, the arm also needs to rotate along this axis here. So I made a mount that goes onto the cross-style servo horn of the 805BB servo. So that'll attach here, and it also has a mount for another servo. And this is what's going to control our rotation. I'm not going to use a continuous rotation servo because I don't want to have to deal with adding a slip ring in here. So this is going to rotate 90 degrees in each direction. So from here it's going to rotate, oh, that's not the right, from here it's going to rotate 90 degrees this way and then 90 degrees this way. And that's going to be our main rotation. And that's going to be controlled by a standard servo. And how that's going to attach is with a servo horn that has a M5 rod coming out of it. It's actually an M5 screw. You can see it here in X-ray mode, make it white. So this is going to start here at the servo horn and travel through where we have the other servo and into the arm here. And here you can see it ends there. I'll probably glue that in just for some extra support. And then as that rotates, this whole piece will rotate as well, so that there's a little bit of support for the screw and it's not just hanging here on the servo horn. I printed out this bearing holder. So if we hide that arm, you can see that the screw is going to travel through there. There's going to be an M5 bearing here and another one on the other side where you can't really see it here. And that's going to support the screw, make sure it stays straight as it enters into the arm. I also printed out a mount for this to go onto my test head. So you can see here I have the side of the test head in the model here, and I printed out this mount which will attach to the 805 servo here, and all of this will screw in and we can start testing the functionality on the test head. Here's that all installed on the test head. I also printed out this fancy schmancy little remote control here, just 2 joysticks to control the movements. Okay, I'll power it up here. We can start testing the functionality. We have the shoulder. And while the shoulder's up, we can move the pincer, open and closed. We can move the elbow and the pincer. So I definitely need to add in some stick smoothing. These are moving very quickly and pretty harsh. And I don't even have an end stop on the shoulder, so I could potentially crash it right into the top here. But with some stick smoothing and some end stops, this should work really smoothly. We also have our spin front to back. So if we put our elbow up, we could spin front to back while still using the pincers as well. I think in the end I'm going to do a lot of canned animation on these just because the control is pretty delicate and a little bit difficult. So if I can program in some, like push one button and it does this animation, push another button and it does this, and then even be able to control it manually in a separate mode. But yeah, the controls for this are super delicate, and maybe if I got the hang of it from driving them for a little bit, but I think in the settings of a convention where there's people all around, kids running around, it might just be better to have some canned animation rather than sitting here trying to concentrate on subtle servo movements. So one of the main problems here comes from the shoulder. If we look at the actual chopper model, there is a smaller hole that this arm comes out of. It doesn't have the full reach to the top of the head. So if we rotate our shoulder joint here, we can see that it really does go way past where that hole would be. So that comes from the fact that the shoulder joint is too far inset into the head. If we can move the pivot point of the shoulder more outward through that hole, then we can get more rotation upward. So that's going to come from changing the configuration of this arm mechanism a bit. The current shoulder hub needs to be reduced to allow it to move closer to the interior wall of the head. The interior walls themselves will have to be refined a bit to allow all this extra room. Also, we're going to have 2 arms that theoretically move out of the head along the same plane, so we're going to have to figure out how to make that a little bit more plausible. All this points to the next step of the build being the development of the final head model. I was hoping to have the arms moving in and out before I started building that, but there are way too many variables involved, so it's probably smarter to start integrating them into the design as I go. I do, however, have a pretty good idea of the hardware I'm going to use for the arm movement. I purchased some linear slides which have this little carriage on them. The carriage is loaded up with ball bearings that make the motion really smooth as it moves along the 8mm rail. So attaching those carriages to the assembly should be all we need to get the arms moving out of the head smoothly. So here's our basic head shape. You can see the arms fit pretty nicely inside of there. As far as how I'm going to address the 2 arms moving out of the same plane, I came up with this idea. If these pink and purplish lines represent the center axis, I've offset the openings for the doors just a little bit, about a 1/2 inch in each direction off of that center axis, to give it a little room. And in addition to that, I have tilted each of the arms about 3 degrees. So from a top view, it's pretty obvious what I did, but I don't think even the most astute person would be able to see that from any other angle unless they're, really looking for something wrong from the front. It should look pretty normal. And especially if the head's rotating, there's no way you're going to be able to detect like a half an inch and a couple degrees rotation. So that'll solve a pretty big problem of getting the heads out the doors. So next up is just going to be a lot of refining and getting these arm mechanisms completely optimized to get in and out of the head and setting up those rails for the actual motion. So we have some functional arms. I think that's going to do it for this video. Between now and the next video, I will really start designing the new head and get everything set up. In the next video, we should hopefully see the final versions of both arms moving in and out of the final head, maybe with some canned animations. Be sure to subscribe if you like these videos. Also, check out the links in the video description for some of my social media accounts, and I'll see you next time.